Hello, this is Hemanta Saxena here. I'm going to present a demo video for class 9 physics chapter 8 motion. Class 9 subject physics chapter 8 motion. So here in this video we are going to cover the topics describing motion, measuring the rate of motion, rate of change of velocity, graphical representation of motion. So let's start with the first topic describing motion. Here in this chapter we will understand motion, what is motion, what are the types of motion, how actually it works. So here let's understand what is motion. Motion means movement. As you all know, what motion is actually means, it means movement. What movement? Motion means what? Movement. In everyday life, we see some objects at rest and some others in motion. As we know, in everyday life, we see many objects which are at rest. Rest means no movement, they are stationary, they are at rest, and some objects are in motion, means some objects are moving. Okay, so rotation and revolution of earth, continuous expansion of the universe, ball rolling down the hill, a train traveling along the tracks, etc. are all examples of motion. What? Rotation and revolution of earth. As you know, earth what? Rotates on its axis and revolve, so that what it is also examples of motion. Means earth is rotating means earth is what? Moving. So this is also what? Motion. Continuous expansion of the universe. As we know, in the universe it is continuously expanding, so that what? It is in the movement. So what? Continuous expansion of universe, also example of motion. Ball rolling down the hill, a train traveling along the tracks. As a train travel means a train moves on the tracks, it means what? They all are the examples of motion, means all these objects are in movement. So what? This is what? Motion. Here we will understand the definition of motion. What is the definition of motion is given here. Motion is a continuous change in the position of an object. Means what? Motion is a continuous change. Change means movement. Motion means what? Movement. Movement means what? Change in the position. So motion is a continuous change in the position of an object. Means when an object is changing the position, it will what? It is in a change. It is in a continuous change with the position of an object with respect to a stationary object. Means one stationary object, with reference to that stationary object, if any object is moving, it means you will say that object is what? It is in the motion. It is described in terms of displacement, distance, velocity, acceleration, time and speed. Here it means what? The motion that is described in terms of many here terms given. In that in those terms we will understand actually what? Motion. In the terms of displacement, means along with the motion we will understand what? Displacement, distance, what is distance, what is displacement, velocity, acceleration, time and speed. All these terms we are going to understand along with the motion, and then we will actually know what is actually the motion along with all these terms. So here you can see motion. One more definition and some simple words. It is given that a body is said to be in motion when it changes its position with reference to a fixed reference point called the origin. Means if any body is changing the position with reference to any point, so that reference point will be called the origin, and the body which is moving, that is what? The body in motion. Means if any body is changing its position with reference to a point with reference to any other body, so that reference point will be called as origin. Okay, now in motion we are having uniform motion and non-uniform motion. So we will understand what is uniform motion and what is non-uniform motion. So let's read what is uniform motion. Uniform motion is a motion in which equal distance is covered in equal time intervals. Uniform means same. Here we need to understand the word what? Uniform and non-uniform. Uniform means same and non-uniform means not same. Okay, so uniform motion means what? It is a motion in which equal distance is covered in equal time interval. Equal distance means every time if you are traveling at some distance, and if you are traveling somewhere, if you are traveling same distances in same time interval every time, okay, equal distance and equal time, so that motion, that movement means in equal distance covering in equal time, so that distance, that motion is called uniform motion. Okay, uniform means same. And non-uniform means what? Non-uniform motion is a motion in which unequal distance is covered in equal intervals of time. Unequal distance means, suppose you are traveling somewhere from car or with bike or with any vehicle. So if you are traveling first time, if you have traveled suppose 50 kilometer in 1 hour, and in next hour, in the next hour you have covered 100 kilometer, in the next third hour you have covered 120 kilometer. It means what? Different distances you are covering in equal interval of time. So that means what? Distances are not same. Okay, so here in this case we can say the motion is a non-uniform. Why? Because the distance is not same, and though it is time is same, but the distance is not same. Both the quantities should be same. What? Distance and time. Okay, if your distance is same in every time and with the given equal time interval, then you can say the motion is uniform. And if the motion is and the motion will be non-uniform when the distance is not same in equal time intervals. So here this is the introduction of uniform and non-uniform motion. Okay, so next term we will understand distance. As we all know what is distance, but once in this term of motion we will understand what is distance. It is the actual path travelled by an object from its initial position to final position. Initial position means, but here we will say initial position means the starting position. If the object start to move, so from the position, the starting position it is started to move, so that position, starting position, will be called initial position. So what is distance actually? Here it is the actual path. Actual path means actual area or path where the distance, where the object is traveling. Travelled by an object from its initial position to final position means the distance from the starting point to the ending point. Final position means ending point. So that distance will that path travelled will be actually known as distance. It is a scalar quantity. It means distance is a scalar quantity. Scalar quantity means without direction. Distance only tells us about the distance, how much distance you have travelled. It will not tell you about the direction, that in which direction you are travelling. That is another thing. So it is a scalar quantity. It has only magnitude without direction. Only magnitude. Magnitude means measurement. It has only the measurement without direction, means that distance will not tell you about the direction. It will only give you the distance, that how much far or how much distance you have travelled. Okay, so here with this picture, with this image given here, we can understand what is actually distance and what is the displacement. So here you can see point A and point B. Okay, if you have to travel from point A to point B, so you can take any of the path. As you can see, the one path is given like this. In this way you can travel and you can reach to the point B, and one directly from point A to B directly also. In this way you can go and you can reach. But here we will understand what is actually distance and what is the displacement. So if you are traveling from this way, it means what? It is telling us the distance. And if you are directly from point A to point B in a particular direction, if you are going, so that will be given, that will tell you about the displacement. Displacement also we will understand with the definition, but here we are talking about the distance. So distance means what? You have covered some distance from point A to point B this way, as you can see with my hand cursor. So this is what it will tell you about the distance. Okay, and displacement means what? From directly the shorter distance, if you are traveling from A to B in a specific direction, that will tell you the displacement. So this distance is clear. That distance means a path traveled from point A to point B. So that will tell you about the how much distance you have traveled. This way if you are going, it will not tell you the particular direction. Okay, which direction you are moving, but displacement will give you the direction and will give you the shorter distance. Okay, so here that was about the distance. Okay, it has only magnitude without direction. Now displacement we will understand. Distance and displacement is same, only slightly difference is there, that we will understand. First let's start with the displacement. First point, it is the shortest straight line path between the initial and final position. As we have seen in the image, it is the shorter distance between the initial and the final position, and it is a straight line path. Displacement will be in the straight line path from initial to final position, and it is the shorter distance covered. And if we compare from this way and that way, so we can say this one is a shorter distance, which is what? Displacement. So it is the shortest straight line path between the initial and final position. Okay, as we can see, this one is initial and this one is final position. So a straight line path, shortest straight line path between A and B means between initial and final position. So that is what actually displacement. If the initial and final points are same, if we suppose the starting point and ending point both are at the same point, then in that case how will you measure the displacement? So here in this case the displacement will be 0. Why the displacement will be 0? Because there is no difference in the initial and the final position. There is no shorter distance. It is if it is at the same point, then you will say what? Displacement is 0. Here we can understand. See, suppose from this point A you have started to move. You are moving in this way in the direction, and again you are stopped at the point at point A. Means after covering some distance you have stopped at point A. It means what? Distance you have traveled. Suppose 5 km, 10 km distance you have traveled. So you can say about the distance that how much distance, 5 km, 10 km. Okay. But if we talk about the displacement, if our points are same, so displacement means what? The difference in initial and final position. Our initial position also point A, and our final position means our ending point also again A. If both the point initial and final position are same, then in this case our no shorter distance means the displacement is what? 0. Okay. Now the object's position is its location with reference to a chosen reference point. Means object's position means if any object, if you are talking about any object which is in moving, which is position, so the object position will be its location with reference to a chosen reference point. Means you have to see from which point you have started, from which point you have chosen, that from that point to which point it is moving. So that from the starting point you can say which is what? Reference point. Here you can see displacement. Okay, here see displacement means what? Vector. Why it is a vector quantity? Because it gives you the direction. Okay, so that is why displacement is a vector quantity and distance is a scalar quantity. Only the difference between distance and displacement is what? Distance is a scalar quantity, displacement is a vector quantity. Means distance will not tell you about the direction, but displacement will tell you about the direction. Now in this we will understand relative motion. Relative motion, by the topic name, by the word relative, we can understand the motion which are related to each other, है ना? Suppose any two objects are there, so in their motion something will be related to each other. So that is why the topic is, the word is relative motion, means the motion which is related to another thing or another object. So here we'll see in detail what is actually relative motion. So let's start. When two objects are moving in a plane, either in the same direction or opposite, means suppose you have to consider two objects, they are moving in a plane. Okay, maybe they are in same direction, or either they are in same direction or opposite direction. Each has relative motion with respect to the second, means each one are related with their motion. If they are having relative motion with respect to the second, means each one one related to the other and other related to the first. So they are all interrelated to their motion. They both are related to their motion. Example, let's see an example that what will be the example of relative motion. So here we can see a person sitting on a train and watching a tree. As you may have also experienced while you are going in a train or any bus or any vehicle, if you are a person sitting on a train and watching a tree, let's see with this let's see this image, this example, that you can see a person sitting in a train and watching a tree. Okay, in this case the tree is stable, but it is assumed to be moving with respect to the train. When you are going by train, or so you may have seen that, you may have experienced that when we see from the window, what we see, what it seems like that the tree is also moving with us, with our train. The tree and the whatever the objects are outside, they are also moving. But actually the tree is not moving. As we know, the tree is stable means the tree is at its own place only, but it is assumed, but it seems like what, the tree is also moving with respect to the train. If the train is moving, so the tree is also moving. So they are what, the tree and the train, they are related motion, they are relative motion, means with reference to the train we see that we seems that it is assumed that the tree is moving. So what, it looks like that the tree is moving, है ना? So that with reference to the train it is happening. So they are what, relative motion, they are related to each other, है ना? So that's why we will say this type of motion, this type of example, this type of cases are for what, they are of relative motion. Here in this image you can see that if the person, here it is, the train is moving here in this direction. So the when you are looking outside of the window, you will see that the trees are moving in the another opposite direction. So that are what, relative motion. As you can see, the direction of passengers motion, here this is the direction of passengers motion, and the trees direction in this direction. So this is what, relative motion. Now the next in this we will understand motion along a straight line. If you know a straight line, you know a straight line. If any object is moving in a straight line, so what motion, how motion will be in this? When an object moves in a straight line with respect to the observer, then the motion is called a straight line motion. If this is very simple, that if any object is moving in a straight line, okay, with respect to the observer, means if any observer is observing that any body, any object is moving in a straight line, so that motion will be called as a straight line motion. So then the motion in a straight line, we can call it as a straight line motion. If a body starts from A, let's understand an example. If a body starts from A, goes to B and comes back to A, means from one point A it is started, it has travelled one point B, from A to B, covered some distance, and after B again came back to A. So in this case, then distance covered is, means some distance covered from A to B, and again from B to A it is going to, again some same distance is covering. So suppose A to B it has covered 35 km, and from B to A again it is 35 km. So total distance is how much? 70 km, but its displacement is 0 km. How this? Let's understand. Here see, this is point A, okay, this is point A, and this is point B. Okay, if any body starts from A and A to B, it has covered how much distance? It has covered 35 km. Okay, again from B to A it is going, okay, from A to B it has covered some distance 35 km. Again from B to A it is covering how much kilometer? 35 km again. So total distance is how much? 35 plus 35, 70 km. But from A it is started. Again after starting from A, again it is stopped at point A. Okay, so in this case, what, initial and final position both are same, points are same, initial and final points are same. Okay, in this case initial and final points are same, so displacement is what? 0, because initial final position are same, and no shorter distance in this, because starting and ending point is same. So in this case we can say displacement is 0, but the distance is 35 km. Okay, is it clear? So that is what distance and displacement. Here in this we can see motion in a straight line. If any object, if any body is moving in a straight line, so that motion is called motion in a straight line. Okay, now measuring the rate of motion. Rate means what? Speed. means motion with how much speed, the movement is there. So how will you measure the rate of motion? So in this case we will measure the rate of motion. A moving object may not always be in a uniform motion. Uniform motion, we have understood what is uniform motion. The body moves, the body covers equal distance in equal time interval. That is what uniform motion. So what, a moving object may not always be in a uniform motion, as we know that every time every object will not move in a uniform motion. Okay, the rate at which an object moves can be different. Maybe the object is traveling with the non-uniform motion, means unequal distances and equal interval time. Yeah? So the rate at which any object moves with a different speed, with the different distances. So objects moving with different rate will take a different amount of time to cover a given distance. If objects are moving with the different rates, so they can have a different amount of time also to cover a distance. Okay, so one of the way of measuring the rate of motion of an object is to find out the distance traveled by the object in unit time. How you can measure the rate of motion of an object? To find out the distance, how much distance is traveled in a unit time. If you know about the any object distance in a unit time, then you can find the rate of motion. Means the rate means what? Speed. Speed means what? Speed means what? The distance traveled upon time and taken. What is the speed? If any object travels some distance in a unit time, so that distance upon time is gives you speed. So that is only here. If we find out the distance, how much distance is traveled in a unit time, then we can find the measurement of the rate of motion, means the speed of motion. Here, as the distance is to displacement, means distance and displacement are same, only difference is about the direction. Distance not give you direction, displacement gives you direction. So distance is also displacement, so speed is to velocity, means if you consider distance is also displacement, it is same only. So distance is to displacement. If distance is displacement, then we can say speed is to velocity. Speed also same in the case of speed and velocity. Speed is doesn't tell you about the direction, but velocity tells you about the direction. Okay, so speed is to velocity. Speed and velocity are same, only difference is about the direction. The crucial difference between the two is that the speed is a scalar. Only the difference, a small little difference is what? A slightly difference is what? That speed is a scalar quantity, will not give you the direction, and velocity is a vector quantity. Velocity is a vector quantity, means velocity gives you the direction. In everyday conversation, we usually say speed when we talk about how fast something is moving. And if you do any conversation, if you are talking with someone, if you are talking about the motion, speed and also, what we usually say, that how much far if any object is traveling, so we will say how fast something is moving, with what speed, we talk in terms of speed. So however in physics, it is often important to determine the direction of this motion. If you are using this term in the physics, so it is important to know, to determine the direction of the motion, in which direction the body is moving, the object is moving. So one finds velocity come up in physics problem far more frequently than speed. So if you are talking about the direction of motion, then you have to find velocity. Okay, velocity gives you the direction along with the speed. So that term is used for direction of motion, what? Velocity. Okay. A common example of speed is the number given by the speedometer in a car. As we know, speedometer means which speedometer is a device which is used in the meter of your vehicle. So that speedometer tells you about the speed that your vehicle is traveling with what speed. So a speedometer tells us the car's speed. We know speedometer what it tells. It tells about the car's speed, not its velocity. It does not tell about you the velocity, that how much velocity, because it gives only a number and not a direction. Speedometer will show you only a number. That number will tell you that how much kilometer. It will not show you a direction. So speed is a measure of the distance an object travels in a given length of time. Speed is what? It is a measurement of the distance traveled in a unit of time. So that is what speed. Speed formula we know, distance traveled per unit time, and its SI unit is meter per second. Okay. Now average speed, average we know what is average. In mathematics also we find average. We find out the average means what, the total item if we talk about the speed, if we have different speed, different distances in different some different time interval, so how would you find average speed? Average means total distance traveled divided by the total time taken. Total distance traveled means, suppose in 1 hour you have traveled some distance, in another second hour you have traveled some another distance and all. So total how much distance you have traveled, in total how much time. Suppose in 5 hours you have traveled different kilometers in different hours. Okay, so you have to add up all the distances and you have to divide it by the total time. So you will get the average speed. Okay, formula is what, total distance upon total time. And total distance, suppose in 5 kilometer in 5 hour you have traveled 50 kilometer. So 50 divided by 5, you will get 10. So 10 is your average speed. And SI unit of average speed is also same, as units speed is meter per second. Velocity, it is speed in a specific direction. Velocity is same only. What is velocity? It is also speed, but it is in a specific direction. So that it is a speed in a specific direction, or displacement, we can say displacement per unit time. Why? Because speed is a vector quantity. It also gives you the direction. That is why it is a speed in a specific direction or displacement in a per unit time. Now average velocity. What is average velocity? As we have find the average speed, same way average velocity. Arithmetic mean means arithmetic mean of initial and final velocity. Velocities, as we know, starting velocity and the ending velocity. Final velocity means, starting means initial velocity, ending means final velocity. You have to add and you have to divide, because we have two velocity, initial and final, so you will divide it by 2. Okay. If acceleration is constant, we will understand also acceleration. What is acceleration first? But here average velocity, what is the formula of average velocity? U means u here, u plus v upon 2. U means what? U is the initial velocity plus v is the final velocity. U indicates initial, v indicates final. The sum of initial and final velocity is divided by 2. Why 2? Because initial and final two velocities, therefore we are dividing it by 2, and its SI unit is meter per second. Now we have understood the rate of motion, rate of change motion we have understand, measuring the rate of motion. Now the next we will understand rate of change of velocity. Velocity means what? It's a speed with direction. We know velocity. Change of velocity means what? If the speed is changing in the during traveling time, that means velocity also changing. But with what speed? With what how much fast the velocity is changing? So that rate, if you have to find, you need to find what? You need to understand rate of change of velocity. First point, the velocity of an object is the speed of an object moving in a definite direction. We know that what velocity, if any velocity of an object is not, it is the speed of an object moving in a definite direction. Second point, the rate of change in the velocity of an object per unit time is referred as acceleration. Means what? The rate of change in the velocity means, if we are if you have to find the change in the velocity, means with what rate? If the rate with the change in the velocity of an object per unit time, it is referred as acceleration. Means the change in the velocity of any object in a per unit time, that change is known as acceleration, and the kind of motion is known as accelerated motion. And in that motion, means in which the velocity is changing, so that changing velocity is referred as acceleration, and that motion is also known as accelerated motion. Acceleration means understood change in velocity. Velocity sometimes increase, sometimes decrease. So there is what? Changing. The speed is changing. Okay, so that change is called acceleration. Acceleration means what? Changing in the velocity. The rate at which the velocity changes, with what rate, with what speed the velocity change. Okay, so that rate, that word is given acceleration. means change in velocity. To compute the rate of change in velocity or acceleration, means that if you have to measure the rate of change in velocity or acceleration, if you say change in velocity or acceleration, means it is same. So the initial speed is subtracted from the final speed. If you have to find the acceleration or the rate of change in velocity, so you have to subtract the initial speed from the final speed. Means final speed minus initial speed will gives you the acceleration. This rate is then divided by the total length of time period for the acceleration. Means if you have to find the acceleration, the final velocity minus initial velocity divide by time, so then you will get the acceleration. This is the formula for the acceleration. Here more you can understand. Acceleration is a vector quantity that is defined as the rate at which an object changes its velocity. It is a rate, it is a measurement at which object changes its velocity. That is what called acceleration. An object is accelerating if it is changing in velocity. An object means if any object is changing its velocity, means it is the object is in accelerating. The object is accelerate. Acceleration formula we know, change in velocity upon time taken. Mathematical expression we can say A. Here small a letter A denotes acceleration, and V minus U. V is the final velocity minus U initial velocity upon time. The final velocity minus initial velocity upon time will give you the acceleration, and the SI unit is meter per second square. Now here types of straight line motion. Okay, we know straight line motion. If any motion in a straight line, then it is straight line motion. So we have already discussed also uniform motion. Means again will in short we'll understand. An object covers equal distances in equal interval of time. If it is said to be in uniform motion, thus it moves with a constant velocity. If any, it is very important point. If any object is moving in a uniform motion, means equal distance in equal time, then it has speed also, means it has velocity also, means because of the same speed, say in every time, same velocity in every time, the velocity is also same in every time. It means if any object is traveling with the same velocity, same speed, we can say, we will call it as a constant velocity. Means the object is moving with a constant velocity. Constant means same. Okay. Now non-uniform motion, the velocity of body changes with time. Means what? Non-uniform means what? Because of unequal distances in equal interval of time, the velocity will also change. Velocity will not same, speed will not same, so velocity of a body changes with time. Second point, the velocity of an object can change if its speed change. As we know, if any object speed is changing again and again, so its velocity will also change. If its direction will change, means suppose in first time you have some direction, in the next hour you have changed the direction. So means what? If your direction change, it means you are in non-uniform motion, and both speed and direction change. If your speed and direction both are changing, then also you will say it is what? Non-uniform motion, and the velocity of an object is changing. Third, uniformly accelerated motion. Uniformly accelerated. Uniformly means the object is accelerating. Object is means the object velocity is changing, but uniformly. Uniformly means same, with the same rate the velocity is changing, so you will say uniformly accelerated motion. How? The body is in motion with constant acceleration. Constant means same acceleration. Thus the speed of the body moving in a straight line. If any object it is moving in a straight line, so the speed of a body moving in a straight line increases or decreases by the same amount. Maybe the speed is increasing, and when it is traveling on a straight line, or maybe it is decreasing, but in an equal interval of time, with the same amount it is increasing, with the same amount it is decreasing. Means the velocity is changing with the same amount, whether it is increasing or decreasing. So the same amount it is increasing or decreasing, so that is that is why it is called uniformly accelerated motion. Now this uniformly accelerated motion can be positive also, if it is in the direction of the velocity. If the means if it is when it will be in the positive, if it is in the direction of velocity. If the acceleration is in the direction of velocity, then it is positive, and it would be negative if it is opposite to the direction of the velocity. Means if it is opposite to the velocity's direction, means more we will understand acceleration, the rate of change of velocity. Now positive acceleration or negative. Positive acceleration means if it is in the direction, if it accelerates in the direction of velocity, means speed up. When your velocity is increasing, so you will have positive acceleration, है ना. Riding your bike forward, है ना, harder to, when you will, if you have to increase your speed, you have to move more forward. Okay, so that is what your positive acceleration, and negative acceleration in the opposite direction to movement. If you are applying little bit force, means you are in opposite direction of the motion, so you will have what, your speed will decrease. How you will decrease your speed? Little bit force you will apply in the opposite direction of the motion, so your motion will little bit decrease, so your speed will decrease. It means you are in opposite direction of the motion, so that in that case you will have negative acceleration. Means speed is decreasing with the same amount as it was increasing, so that same amount speed velocity is decreasing, then you have negative acceleration. Means speed increasing speed, it will gives you positive acceleration, and decreasing speed will give you a negative acceleration. The car is slowing down. Here you can see the velocity with the same speed, same velocity, but the car is slowing down, the car speed is decreased, so it will have negative acceleration, and the car is speeding up in the direction of motion, in the direction of velocity, so it is positive acceleration. Now the last topic we will discuss graphical representation of motion. If you have understood the motion, uniform motion, non-uniform motion, velocity, distance, and all these things you have understood. But if you have to represent the motion through graph, how will you represent the motion through graph? So here let's understand this. Graphs are very useful and effective methods to provide information. As we know, graphs are very useful, and we use graphs for representing distance, time, and all, and it is very effective method to provide information. Through graph, in a short way, you can understand the information. The motion of an object can be represented by line graphs. Okay, if you have to represent the motion of any object, so you can use line graph, and easily you can represent. So in this graph, when you are representing the motion, you need to understand distance time graph. Now distance time graph, what will tell you? It will obviously, by the name of distance time, it will tell you about the distance and the time of the motion. So the distance time graphs are employed under various conditions where objects move with uniform speed. Means distance time graph will tell you about the uniform speed, non-uniform speed, and remains at rest, etc. Whether the body is in uniform, non-uniform, or at motion or rest, distance time graph will tell you about it. And velocity time graphs are used to know the variation in velocity with time. Velocity time graph will tell you about the velocity in time. Means if any change in the velocity, if any variation in velocity, you can understand by velocity time graph for an object moving in a straight line. Let's understand distance time graph in detail. For uniform motion, if you have to represent uniform motion, distance time graph, so what conditions should be there? A motion is said to be uniform if an object covers equal distance in equal interval of time, however small these intervals may be. As we know, what is uniform motion? A motion in which a body covers equal distance in equal interval of time. Okay, the distance time graph of uniform motion is a straight line. Always remember, whenever you have graph and whenever you have seen a straight line, so that straight line will represent you about the uniform motion. The distance travelled by the object is directly proportional to the time taken. Means distance travelled by will be directly proportional. Directly proportional means in directly relation to the time. If the time is increasing, the same distance also will increase. Means if the same distance is increasing, the time is also increasing. In this example, if it was 10 km every 15 minutes, 40 km per hour. Okay, suppose in every 15 minutes the distance is traveling 10 km. Okay, so in every 15 minutes, so in 1 hour 15. How many times 15 minutes will be there? 4 times. 15 minutes, 15 minutes, 15 minutes, 15 minutes, and every time it is covering 10 kilometer, 10 kilometer, 10 kilometer, 10 kilometer. So in 1 hour, in 60 minutes, so 4 times of 15, okay, 60 minutes. So in 1 hour it will cover how many kilometer? 40 kilometer. Same distances, same time. 15 minutes, 15 minutes, 15 minutes is the same time. 10 kilometer, 10 kilometer, 10 kilometer, 10 kilometer is the same distance. So here you can see same distance in the same time. So the motion will be what? Uniform motion, and the graph will be also of a straight line. Let's understand by this image distance time graph for uniform speed. Suppose here this time is represented. One is here is the first one is representing first 15 minutes. This two is representing another 15 minutes, another 15 minutes. Okay, this way. And here you can see here suppose 0 to 50, 50 to 100. This is the distance. So in the on the first point, suppose here this graph having the difference of 50 in distance and in time in 1, 2, 3, 4. Okay. So here let's understand with this time is in hour and this distance in kilometer. So in first hour 50 kilometer, in the next hour 100 kilometer. So distance is how much? Here 0 to 50, 50 kilometer, and 50 to 100 how much distance? 50 to 100 another 50 kilometer, 100 to 150 another 50. In the third hour and in the another fourth hour another 50. So here you see 50, 50, 50, 50, first, second, third, fourth. Okay, and you can see the straight line. Okay, that straight line tells you about the uniform speed, uniform velocity. Speed and velocity same. Distance time graph, only the difference is about the what? Direction. Now distance time graph for non-uniform motion. Distance time graph of non-uniform motion cannot be a straight line. For non-uniform motion, distance time graph will not be a straight line. The object covers unequal distances in equal intervals of time. Means in this case the object will cover unequal distances, means different distances will be there, but unequal distances in the equal intervals of time. Here you can see 0 to 50, 50 to 100, again 50, 50, 50 difference of distance, and time 1, 2, 3, 4. So suppose in the first hour it has covered some distance, in the next hour less than 100 some distance it has covered, and in the next another 3 hours. So here you see the distance is not same. Okay, 50, 50, 50 different distance is not there. Suppose here it was 20, then here it was 70, then here it is 150, then here it is 200. So distance is not same. So when you will join these points of the this distance and time, you will not get a straight line. It means here you can see a curve that will represent what? Non-uniform motion or non-uniform speed. Now velocity time graph, means velocity time graph will tell you about the velocity and time for uniform motion. Means what? Same velocity in same time. Here again we'll understand uniform motion means constant velocity. Uniform motion means same distance in the same time in same speed, and same speed means same velocity, and same velocity means constant velocity. Velocity time graph of uniform motion is a straight line parallel to the time. As we have seen in the distance time graph, straight line come for the uniform motion. So for the velocity time graph of uniform motion, it will be a straight line. There will be also a straight line, but it will be parallel to the time axis. Okay, in this it will be a parallel. As we can see, this is what? This velocity, this represent time, this is the time axis. So here this line will be parallel to this time axis. Here straight line you can see, it means this line is showing what? It is in uniform motion. Distance covered by a body between T1 and T2, area of rectangle. Okay, here you can see in this T1, time T2, means at the time T1 the body starts, the object start to move. Suppose if the time in second, at the 6th second it started and it stopped as 12th second. Okay, and it was the means it was with the speed of 40. Okay, velocity, we are talking about the velocity and time. So it was when it started, it was with the same velocity, and when it ends also, that time also it was with the same velocity, same speed. Okay, so that the speed is same in different times also. So the same speed line will be same. It will be parallel to the time axis. So this way you can say, if this straight line, if you see parallel to the time axis, it means what? It is the what it is? It is the it is velocity time graph for uniform motion. And you can see area of rectangle. If you have to find distance, so you can find distance by finding the area of rectangle covered. You can see this rectangle ABCD. Okay, so what will be the area? As we can see here, it is 40. Okay, so here will be more detail about this. There will be derivation and all, so you can easily understand. But here we are just talking about the velocity time graph for uniform motion. Okay, now velocity time graph for non-uniform motion. Okay, the velocity time graph is a sloping straight line. Now here will be a sloping straight line, this way sloping straight line. So this way it will not there will be what velocity will not be same distance. Okay, so here in between time t1 and t2, suppose at time t1 the velocity was this, and at time t2 the velocity change, the speed is changed. It means when the speed is not same, velocity is not same at different timings, so you will say what the velocity time graph, it is of non-uniform motion, and the line will be a sloping line and straight sloping line. Okay, it represents the non-uniform motion. Okay, I hope you understood well. Thank you.